student, welcome back. So today we will start 11.3, the addition law of the probability. So you may think that additional law, we have learned it in permutation and combination, chapter 10, right? Yes, they got some relationship, okay? So let's start with the A section first. Total in 11.3, we got ABC session. So today I will only focus on session A and B. So tomorrow we will talking more about the session C. So let's talk about A first. A, you need to learn two important vocabulary, okay? One is mutually exclusive. Another one is non-mutually exclusive, okay? So first of all, let's take a look of what is mutually exclusive. So actually, mutually exclusive told you that actually two of the event, they are totally different. They have no relationship, okay? For example, you can see that event A, okay, we have including the number is 1, 3, 5, 7. This is an odd number. All of them are odd number, right? Then event B talking about multiple of 4, okay, multiple of 4. Anything about multiple of 4, of course, they are even number. It's not an odd number, right? So you can see that A and B, they are totally separate, okay? These two events, no relationship, so we call it mutually exclusive. Is it okay? So mutually exclusive mean two of them, no relationship, no intersection, okay? So now take a look of what mean by non-mutually exclusive. So actually this is just the opposite of the mutually exclusive. So take a look of this example, okay? So for the event C, take a look of this. Event C, we're talking about kings, okay? If you're playing a poker game, okay, you want to draw the king, so total you have 4 king, right? So now event D talking about all the heart card, okay? You take out all the heart. So if you take out all the heart, one of them will be in the event C, is the heart king, right? Because this one is both suitable in event C and event D. So you can see that these two events, they got some relationship. One of the element is the same. So here, we can't say that, oh, two of them no relationship. We can say that, yes, they got some relationship. So we will call it non-mutually exclusive event, okay? So very easy to separate them. If you got two events, event X and Y, okay, they cannot happen at the same time, okay? They will separately. We call it mutually exclusive, okay? So what if the event X and Y, they can happen at the same time? That means it can be at the event A at the same time at the event B, okay? So we will call it non-mutually exclusive. Is it clear? So now we will using a set notation to present it. Okay, it's this one. So you can see that X and Y will equal to, okay, this is empty set. Can you see that? This symbol means empty set. So for example, here, X and Y, can you find any and mean both same? No, we can't find any, right? So this is empty set. So we will present like that. Event X, event Y, okay? They have no common things overlap together, so this is empty set. But if the X and Y event, when they overlap, okay, here, so this is, you got some element, right? It's not an empty set, so we will call it non-mutually exclusive, okay? Clear, right? So now let's take a look of the classwork, okay, to test yourself whether you understand or not, okay? So what we need to do is, if they are mutually exclusive, put a tick, okay? Of course, opposite, if this is non-mutually exclusive, put a cross, okay? So now let's start. So first of all, a playing card is drawn, so event X is the card is red. Okay, remember what mean by red? Red mean if you got a heart, okay, or you got a diamond, okay, it means red, okay. Then is it possible at the same time, okay, you have the space, okay. Do you think that these two events will happen at the same time? Of course not, right? Because this is totally different style, right? So it will be mutually exclusive. Two of them, no relationship, okay? Two of them, no relationship, separate. So now, question 2, a fair coin is tossed twice. There is at least one head. If you toss twice, it will be a lot of the possible, right? It can be head, head tail, okay, or tail head or tail tail, right? Because you chose twice, so those will have 4 outcomes. So now event Y is at least one tail. These two can happen at the same time, okay? Because one head, one tail. Yes, it's possible, okay? X and Y event can happen at the same time. If they can happen at the same time, that means they got some relationship. So this is not a mutually exclusive, okay? So now look at the question 3. An integer between 1 and 10 inclusive is chosen. So that means 1 to 10, you can choose any one of the numbers. So now event X is a multiple of 3. So please list out all the multiple of 3 element, okay? So first of all, 3, 6, 9, right? So from 1 to 10. Now event Y is a multiple of 4. So let's try to list out all the multiple of 4. It will be 4, 8, then no more. So take a look of this. 3, 6, 9, and 4, 8. Do they got any overlap? Same number? No, they don't have anything. So actually they are separate. So we can call it mutually exclusive. Okay, so now last one. Let's take a look of the question 4. A dice is thrown twice. Remember, dice will have what? Number 1 to 6. Now the sum is 8. How can you get a sum of 8? We can be 2 and 6, right? We can be 3 and 5. It can be 4 and 4, right? So of course, when we reverse it, it can be 5 and 3, okay, 6 and 2. Is it possible 7? Of course not, right? Dice 1, 2, 6 only. So this is all your possible, okay, outcome. So now take a look of the event Y. The product is 16. How can you make a 16? 16 can be what? 4 times 4, right? Because 4 times 4 is 16. What else? You may think about, oh, how about 2 times 8? But dice, you won't have the 8. So this one cancel. So now take a look of the event X and event Y. Both of them combine with 4, 4. So that means they have overlap when there is a 4, 4. Okay? So actually, this is non-mutually exclusive. So clear? So repeat one more time. Mutually exclusive can be, okay, they don't have any relationship, they can be separate, okay? Non-mutually exclusive, they have something is the same, okay? They can be overlap, okay? Got it? So this is the session A, talking about 2 very important vocabulary, mutually exclusive and non-mutually exclusive. Now take a look of the session B. So session B, we will learn addition law. So you may think that, wow, addition law, same as permutation and combination, right? So beside addition law, we still have the multiplication law. So stay tuned. 11.4, you will learn about the multiplication law, okay? So now take a look of the session B first. Additional law of the probability, what does it mean? It means that if we want to contain something or something happen at the same time, or something and something happen at the same time, how can we calculate, okay, the probability? So take a look of this, okay? So take a look of the wording first. A, okay, union mean or. So if you're not familiar, you just remember, okay, this is or, okay? We can call it A or B. Otherwise, you can call it A union B, okay? So A or B happen at the same time. What does it mean? Okay, later on we can explain. So another one is A and B, okay? A and B, okay? So how can we find the probability if A and B happen at the same time, okay? So now let's take a look using this example, okay, to find out A or B and A and B first. So first of all, A or B, okay? Or mean either or, we can accept all of them, okay? If you happen here, so A or B element will including 2, 4, 6, because 2, 4, 6 is from the A set, right? Then 3, okay? Because 3 and 6 come from the set B, okay? So 6 is your overlap element. That means both A and B, they got the element 6, okay? So this one we call it A or B, okay? That means A union B. So now next one will be A and B, okay? A and B mean what? Both. We need to happen at the same time, okay? Both happen in A and both happen in B, okay? So which one is both in A and both in B? Of course, only one element, that will be 6, okay? So 6, we call it A and B. Only 6, remember, because they overlap here, okay? Can you see that? So now you can take a look. A or B and A and B, actually A and B will have less element, right? So how can we find out if I know that A is, if I want to use a formula to present it, how can we do it? So A is 2, 4, 6. B is 6 and 3. So normally a lot of the students may think that, okay, A and B, okay, A or B, A or B, it can be, some of the students may just directly adding all of them. Okay, 2, 4, 6, then 6, 3. So you can see that actually you overlap the 6, right? A lot of the students will double count the 6. You may think that, Miss Poon, I won't do it. It's very obvious. I won't double write the 6. Yes, we give you the graph. Of course, you won't double write it. But what if I didn't give you any Venn diagram? I just give you a question, okay? You won't do like that. So we will have the formula to help you to reduce the double count of the 6, okay? So now let's take a look of the formula, okay? So now, first of all, if two of the events are mutually exclusive, okay? Remember in the section A we have learned it, mean two of the events are separate. So A or B, just probability of A plus the probability of B. Very easy, right? Directly. You want to find the A or B? Yes, A plus B. Done. But if this is non-mutually exclusive, because they got some overlap, right? So when you're doing the plus, a lot of the student may think that, okay, you give me the formula, okay, is if I want to find the A probability of A or B, that's mean probability A plus probability B. Is it true? Look at the example I just gave you. If you really doing probability A plus probability B, you can see that you double count the 6. Can you see that? How can we to negate this one? Okay, just reduce our error. We won't double count it. Remember, you need to minus the 6. So what is the 6? 6 is A and B. Can you see that? 6, we can call it A and B. So actually, when this is non-mutually exclusive example, you need to minus the double count item, okay? So your formula will be probability of A plus the probability of B, then minus their overlap element, A and B, okay? So remember, so for example, just like this one, yes, A and B, we double count the 6, right? Never mind. We just minus both of them, A and B one, that means 6, okay? So that means you negate one of the 6. The final answer will be just 2, 4, 6, 3, okay? To make it 100% correct, okay? Because sometimes you double count it. Got it? So repeat one more time. If you are mutually exclusive question, your probability formula will be, if we want to find the probability of A or B, will be just directly probability A plus the probability B. But if this is a non-mutually exclusive, because they will have overlap, so we will double count it. So what you need to do is, when you're doing the adding, don't forget to minus the overlap one, A and B, okay? So be aware, one is or, another one is and, okay? They are different. Don't mix up them, okay? So this is how can we, using the formula to calculate the mutually exclusive and non-mutually exclusive question, okay? So now, If you know how to do it, let's try, okay, to do some quick practice, okay? So now take out your textbook, try to do the quick practice 11.4 to 11.6. Then later on in another video, we will explain the answer, okay? See you later. Bye.